Hello and welcome to my Lab 5 monkey and ball analysis. Here's a table of contents of what this lab will go over. And we'll start off with an introduction. The lab's purpose is to analyze the video Shoot the Monkey from this YouTube link. This is akin to the Shoot the Monkey video that was shown in class earlier in the semester, and the goal is to take the real life video and a glow script experiment and compare the two and see how they differ. Important models for this will be Newton's second law and the momentum principle, specifically the velocity update formula, and using that for a curving motion. Here are the beginning results, concepts, assumptions, and ideas. So again, the momentum principle, Newton's second law. It is going to be with Newton's second law and a curving motion, gravity. Velocity is constant in magnitude in glow script, meaning that there is no loss of speed. However, there will be a change of direction. So magnitude of velocity is constant, but not velocity itself. The assumption for the lab is that in glow script, there's no time for acceleration, whereas in tracker, I just take the information as is that was given to me from the YouTube video. Experiment and code. Here's some screenshots from the YouTube video, the ball speed being 9 meters per second. We're taking the system to be the ball and the monkey. Surroundings are gravity, force pushing the ball, the cannon, and the electromagnetic force that turns off. So the monkey is being held up on this tower by a sort of electromagnetic pad, and there's a switch to launch the ball and drop the monkey at the same time. So these initial conditions are the initial positions. These are pulled out of the tracker application. And I'm assuming no initial speeds or velocities. So for the real world experiment, there's an experiment space. You set monkey and ball to launch at the same time. The cannon angle was aimed directly at the monkey for the purpose of the video, and then you fire and watch them hit. This is a screenshot of the tracker application. Distances were set and given to me from the YouTube video. And just to note, around shot 48 is what I consider the end of glow script, because that's the moment of impact where the ball meets the monkey. As for the glow script virtual code, initial positions are from tracker, net forces are gravity on the monkey, and I assume only gravity on the monkey, plus gravity and the cannon force on the ball. So the ball I assume to be a golf ball, the weight was not given. So a golf ball weighs nearly 45 grams, and it was traveling at 9 meters per second velocity magnitude. So the velocity update formula is velocity final equals velocity initial plus F net divided by mass. So if I assume velocity initial to be 0, it's velocity final equals F net divided by mass. So velocity final times mass equals F net. So 45 grams times 9 meters per second is 0.413 newtons. And that is the magnitude. So divided into the x and y directions, you get these two values. And those are the values inputted into glow script for the ball's net force plus gravity. So the first half of this code is pulled from Lab 2, which was the ball drop. And the second half of the code is pulled from Lab 1, which was throwing something at a constant velocity there. And I take the time where they meet to be the final time to compare the two. Post-experiment discussion. So for the X position, the graphs relate very similar. Orange is monkey, straight line up until the monkey is hit, and curved line is ball position. The two meet up at roughly 1.8 seconds. However, when it came to trying to figure out values for the other two graphs, one met up at 1.22 seconds and the other at 8.8 seconds. Similar things happen in the Y graph, 0.8 seconds and 0.122 seconds, even though they met up at 1.8 seconds in real life. Possible errors on this are tracker and the lack of frame rates for object movement, delays of the switches, or an electromagnetic delay that the monkey did not drop immediately, glow script difficulties that I could not pull numerical value directly, and instantaneous movement, unreal acceleration. Glow script does not assume any acceleration, it just assumes it goes. And here are just some methods of possibly fixing this in the future. And questions and conclusions. What if the projectile were shot at a different speed? The video does show this, that aiming at a different angle will still cause the monkey and ball to hit. If the monkey was released via mechanical force, that might figure out the electromagnetic delay, and if the experiment occurred in a vacuum, we might get a better result that's more akin to the glow script code. Thank you for watching.